Hello geometry students, this is Mr. Luya, and in this video I'm going to go ahead and cover the circle chapter test review number 1. So the most overwhelming thing about circles is knowing what formula to use and just by recognizing whatever you see in the picture. So hopefully this video with just more practice in general, it'll help you guys figure this out a little bit better or give you guys enough practice. So what you'll notice with the circle in number 1 is we have two lines that pretty much intersect right there on the circle. And essentially what they want us to find is they want us to find the value of x. So the thing is, x is connected into this arc over here on the outside, but we don't really have any information about that arc. What we do have information about is we have information about this arc. And the thing is, even though we don't have information about this arc quite yet, we know we can figure that out because we know that the arc QS, right? The measure of arc QS is equal to whatever this angle is times 2. Because you have to remember, this angle right here is half of the value of whatever the measure of the arc is. So I know that that if I multiply that angle by 2, that'll give me the value of the arc. And 67 times 2, I probably should have grabbed my calculator, but I can do this. It'll be 134. So I know that this angle right here is 134 degrees. So now I have to remember the other property about my circle, which all of us seem to remember. But if I think about all of the arcs in a circle, all add up to 360 degrees. That is not very visible, so I will erase it. So anyways, sorry, I'm still getting used to this whole iPad thing. So now I can go ahead and add all of my arcs together. So 120 plus 134 plus 5x plus 21. And then all of those together equal 360 degrees. So now I'm just going to go ahead and combine pretty much my like terms. These first two will be 254 plus 21. I'm just going to pull out my calculator. It is in the early morning and I am just not feeling it. So 5x plus 275 is equal to 360. I'll subtract 275 from both sides. Then I get 5x is equal to, that's just pretty much algebra from here. So I'm going to have 85. And then when I divide both sides by 5, I get x is equal to 17. And there you go. I pretty much have my first answer. Let's see. Well, let's look at this circle. Again, it looks like we kind of have the same situation. We have this line and this line that intersect each other on the circle. And you should remember that this angle, and I'm going to write a generic form. Just remember, say it out in your head. The angle is 1/2 the measure of the arc. Okay, so whenever we want to set this formula up, we can go ahead. I'll use purple here. I'm going to say that this is our angle 83, and that's equal to 1/2 the measure of this arc right there. Now, some teachers teach it a little bit differently. They say, well, I don't want to deal with this fraction right here. So why don't we just do 2? Like they would probably say 2 times the 83 is equal to the arc itself. I don't set it up that way. 1, it's an extra formula you have to remember. And 2, I really like the idea of getting you guys used to seeing what you do with a fraction inside of an equation. It's something you'll see in more advanced level math and something that I feel like, we need to address that early on. So either way, to get rid of this fraction, I know my kids are really good about this, is you multiply both sides by that denominator. And so that pretty much cancels out this 1/2 and that 2. And now you pretty much have what some teachers have already taught. We just took an extra step. So then 2 times 83, what does that give me? That gives me 166 is equal to 9x plus 40. I'm going to subtract 40 from both sides. I get 126 is equal to 9x. And then 126 divided by 9 finally gives us x equals, I guess I'll show the dividing step. Divided by 9, x is equal to 14. Now granted, was that what the question was asking for? Yeah, they were just asking for x, so we're good there. All right, Now, here's a problem that at least my students haven't seen in a while, but it's pretty much a very easy concept. If I have look at this angle right here, because that's one of the angles that's given to us. We have that angle, which we know is 6x minus 7. You can see that that angle is connected to this arc right there, right? Whereas likewise, if I looked at this angle, let me, color can I use for that? I'll use orange, how about that? But if I look at this angle right here from WYX, you'll notice that it's also connected to that same exact arc. So hopefully that'll jog your memory and help you recognize that these two angles are pretty much the same. If the same angle is connected to the same arc, I shouldn't have said same angle, but if two angles are connected to the same arc, then they are pretty much the same angle. All right. I didn't get jumbled up with my words there. So now I know I can get those two and set them equal to each other. So I have 6x minus 7 is equal to 10x minus 47. And now I'm just going to do my algebra. I'm going to add 47 to both sides. At the same time, I'll subtract 6x from both sides. Those cancel. And now I have 40 is equal to 4x. And then I divide both sides by 4. And then I get x is equal to 10. All right. Was that what they were asking for? No, they were asking for arc WX. So they actually wanted you to find what this arc was. Well, I don't know what that arc is, but I now that I know what x is, I can plug that into one of these angles. So I'm going to go ahead and plug that in. So maybe this angle is 10 times, now I know x is 10 minus 47. So that's 53. So let me erase this little region right here. So now I know that this is 53 right there. And then again, to go from your angle to your arc, that is an inscribed angle that we have right there. So all we would have to do is multiply this by 2 to get our arc. So the arc itself, actually, I'll just do that over here. So I know that the measure of arc WX is equal to double whatever the angle 53 is, which gives us 106. Okay, so let's look at number 4. If I see number 4, here we have a quadrilateral inscribed of a circle. So again, it's just a matter of remembering what the formulas are and remember what the rules are. If I have opposite angles inside of a quadrilateral, then those opposite angles, right? I'm going to write that down up here. Opposite angles in an inscribed quadrilateral. Wow, my handwriting is awful right now. In an inscribed quadrilateral are supplementary, right? Maybe that's a good way for you guys to remember all of these rules. Maybe write them out every time you see a problem like that. But anyways, I know that these opposite angles are supplementary, which means that if I get this angle plus that angle, they will both equal 180 degrees. So I have 8x minus 31 plus 4x plus 7, and both of those together will equal 180 degrees. So now, again, we're just going to go back to algebra. So 8x and 4x gives us 12x. Negative 31 and positive 7 gives us minus 24, and that's equal to 180. I'll add 24 to both sides. 12x is equal to 204 divided by 12. And then x is equal to 17. Is that what they were asking for? No, they were not asking for x. They were asking for the angle DGF. So DGF, which one is that? That from D to G to F? They're talking about this one right there. So we'll just go ahead and plug in x into that expression. So 4x, so it was 4x plus 7. So DGF is equal to 4 times x, which was 17, plus 7. So 4 times 17, 4 times 17, I should have just done that in my head, is equal to 68 plus 7, which ultimately equals 75 degrees. All right. So let's go ahead and look at this one. Now we have an intersection that's inside of the circle. So again, there are a couple of rules that have to do with that, and the rules are different whenever we're looking at the segments versus the arcs or the angles, right? So make sure you use the right formula when necessary. So what they're asking for here is what is the measure of angle QTS? So this is ultimately the one that they're trying to find. And you have to remember the relationship between the arcs and the angles when there is an intersection inside of the circle is that the arcs that are connected to it, right, will be involved. So you have to remember that this angle, I'll just go ahead and write it as such. The angle, the measure of angle QTS is equal to 1/2 the measure of this arc plus this arc. All right, this is one of the ones where we have to add the two arcs together. And some of them you have to subtract, so make sure you know when you do that. So it'll be 1/2 times, we can just do 80 plus 154. And that's just a simple calculation. We could just do 80 plus 154. This is embarrassing that I'm relying on a calculator for this, but that's fine. It'll be equal to 1/2 times 234, and then half of that is equal to 117. That was a pretty straightforward problem, so we're good. So this is 117 degrees. All right, let's go ahead and move on to the next page. So in this page here, we have an intersection that's outside of the circle. All right, so here, where if the intersection is inside of the circle, you have to remember that you add both arcs. But if the intersection is outside of the circle, there's going to be some form of subtraction. So what you got to remember when it's outside of the circle is the angle, right, is equal to 1/2 times, and I'm just going to say big arc minus the little arcs. I'm going to put it in words. Maybe that'll help you actually see what exactly you're supposed to do. So let's first figure out what the angle is. Well, the angle is given to us. And then the other thing that was given to us is the little arc. All right. And I bet you the problem's going to ask us, they're asking us what is the value of the big arc. So that's what we'll do. The big arc, I don't really know what that is. So I'm just, typically when we don't know what something is, I'm just going to label it as an X. And then now I have everything I need to set up my formula. So my angle was 59. So that's equal to 1/2 the value of the big arc, which is X, minus the little arc, which we now know is 21. And so you guys need to make sure that you practice getting rid of this fraction. So I'm going to multiply both sides by 2. The 1/2 and the 2 cancel out. So now I have 2 times 59 is 118. And then that's equal to X minus 21. So I'm going to add 21 to both sides. So then this is X is equal to, let's see, 118 plus 21 is 139. So 139 is our answer for this one. Okay, so if you are watching this video and you're in geometry regular, I would probably recommend that I always recommend that you sit through any math problem and learn as much as you can. But I'll be honest with you, this is not going to be expected of you on the test. This is more of a geometry honors sort of question because, there is a lot more involved, a lot more factoring required. So I'll go ahead and do this problem, but if you're in geometry regular, just keep in mind that I will not include anything like this on your test. But at least the setup is something that's worthwhile to sit through. So here we have an intersection that's inside of the circle, and this time what they gave us were the segment lengths. So I'm going to look at these segment lengths, okay? And again, the relationship that you have to understand between the segment lengths is that you can multiply the two parts of the same segment, so x minus 6 times x minus 1, and that's going to be equal to, let me put equal to, the measure of both of the other lengths of the other segment. So it'll be 12 times 10. Okay, so you're going to go ahead and multiply this out. So you have x squared minus 6x minus x, did I do that right? Yeah. Minus 6x minus x plus 6 is equal to 120. And so if you go ahead and combine all of your terms, you'll end up with, whoops, what just happened? Yeah, you'll end up with x squared minus 7x plus 6 is equal to 120. So now you can subtract 120 from both sides, and you're left with x squared minus 7x minus 114 is equal to 0. Now, this is the part where you would pretty much be required to go ahead and factor this out and figure out what x values would work for that. I'm going to go ahead and leave that for you guys if you want to go ahead and finish it. But for the sake of not making this video longer than I want to, I'll just go ahead and leave it at that and leave that as a nice little challenge problem for you that you can double check with your teacher. So moving along. And then the truth is, I think that was this problem was a mistake when we put it together, and I didn't realize it until after making this video. While making this video. But anyways, we have this intersection outside of the circle. So this is a much more doable problem and something you'll likely see. And so you have this arc or this segment right here and this segment right there. And now you have to understand what is the relationship of the segments when the intersection is connected outside of the circle. So I always tell my students, and the phrase that I have them remember is outside times the whole thing has to equal the outside of the other times the whole thing. Okay? So I don't know if that makes any sense, but I'll set up the formula, the equation for you, and maybe it will. So here you see how if we look at this segment right here, this 9 is on the outside. So that's what I mean by the outside value. And then I'm going to multiply that by the whole thing of that segment. So the whole thing is not just the 9, but it's also the 2x minus 7. So I'm going to do 9 plus 2x minus 7. And that pretty much gives me the value of the whole thing. All right. So I'm going to go ahead and set that equal to, again, the outside, which is 10, times the whole thing, which is not just 10, but also 8, right? Some of you probably will just say, oh, why didn't you just add it in your head? Well, I like to show the full setup, so that's why. So I'm going to go ahead and combine my like terms. I have, why did it switch to an eraser? So now I have 9 times, and then we have the 9 minus 7, that's 2 plus 2x, and that's equal to, this is 10 times 18, which I probably should have just written as 180, but that's okay. So now I'm going to go ahead and distribute my 9 to both terms, and I have 18 plus 18x is equal to 180. Then I'm going to subtract 18 from both sides. 18x is equal to 162. Divide both sides by 18, and then finally x is equal to 9. Was that what they were asking for, was x? No, they were asking find the measure of mn. So they want to know the measure, they're really only interested in knowing the measure of that right there, which we know is 2x minus 7. So we can just plug in 9 into that. So it was 2 times x minus 7, so 2 times 9 minus 7 is equal to 18 minus 7 is 11. And there you go. All right, let's move on to the next problem. Ooh, here's another situation where we have an intersection outside of the circle, and this is really no different. You have the outside, 9, times the whole thing, which we know the whole thing is not just 9, but also 3x plus 1, so we're going to add them together. And this is equal to, and then this is just a small variation of the same thing. Here we have the outside number 15, right? But then, again, don't we have to multiply that by the whole thing? Well, the whole thing is already 15, right? So that's why when you see the formula, it says just if it's a line tangent to it, it's this number squared. I just tell my kids, just again, one less formula to memorize. Just do outside times the whole thing times outside times the whole thing, and these two happen to be the same number. So I'm going to go ahead and work this out. So I have 9 times, and then I combine my like terms. So that's 10 plus 3x, and that's equal to 15, and 15 is 225. So now I'm going to distribute my 9 to both terms. So I have 90 plus 27x is equal to 225. I subtract 90 from both sides. So now I have 27x is equal to 135. Divide both sides by 27. And then I get x is equal to 5. Now, what was it that they were asking for? Find the measure of AC. Well, AC is this whole thing. So this whole thing right there. So I'm going to go ahead and plug in 5 into this and also add it with the 9. So I'm going to have 3 times 5 plus 1. And the whole thing also includes 9. So 15 plus 1 is 16 plus 9 is 25. So that gives us our answer right there, 25. Okay. And then finally, prove that two circles are similar. This is one of the newest topics. In fact, the very last topic that we learned in this class. And again, there are 2 steps to making sure that two circles are similar. First, you got to do the translation. And then the second step is you got to do the dilation, or find the dilation k. Actually, you know what, let me say instead, figure out the scale factor, because that's essentially what k is. All right. So as far as the translation is concerned, let's go ahead and say, well, we're mapping A onto C. So this is kind of like the original circle, and this is the new circle that we're pretty much trying to translate it onto. So our point A was, let's see, it's at 3, 4. So 3, 4. And then point C, that got mapped onto point C, which is 0, -1. So again, your goal here is to come up with a transformation rule that led you from this point all the way up to this point right there. So you got to ask yourself, okay, well, how do I get from 3 to 0? And remember, with translating, you're only adding or subtracting numbers. So what number do I add or subtract to 3 to get to 0? Well, what I did was, if this was my original x, I got my original x, and I had to subtract 3 to get to that number 0. And then I do the same thing with my y. So how do I get from my original y value to my new one? So my original y value, to get to the new one, you had to subtract 5. So to get from 4 to -1, you had to subtract 5 to that. So there you go. That's pretty much half of the battle right there, as you came up with your translation rule. And then the other thing with the scale factor, you have to come up with, you have to use the formula k equals r new divided by r original, right? So the radius of my new circle, remember the smaller one was the new circle. So my radius has a distance of 1, so 1 and 2. So my new circle has a radius of 2. And then my original circle has a radius of 1, 2, 3, 4, 5. So if you know how to count, you can do just fine. Armani would remember that. So here we have 2 divided by 5, and that's pretty much it. You can either leave it as a fraction. Sometimes you might see it as a decimal. Either or is fine. So the original circle translated from using this rule, and then it got reduced with that scale factor of 2/5. So I'll go ahead and end the video there. That way we're not spending, that way this doesn't take up the entire time. But hopefully you guys found that helpful, and I'll see if I can make another video for the review number 2, and then you guys should be in good shape. Good luck, and have a good day, and ask your teachers if you need any help. Take care.